Welcome all. Welcome to the first session of Computer Aided Designing and Analysis. M308, Module 1. This subject is for S6 Mechanical Engineering students of KTU. So, the first module consists of the introduction to CAD, what are the basic geometrical designs, what are the components of software components and hardware components of using for CADs and all. These are the basic introduction to CAD. What are the things comes under the basic introduction of CAD. Introduction to CAD from the centuries later before that development of computer or computer designs are came. In this century, the rapid development in the field of computer in both and hardwares and softwares are increasing more. The rapid development is happening in the field of computers in both hardware and software. With the advance of very large scale integration technologies, computer hardware is gradually getting cheaper and now they are within the financial range of most of the industries and organizations. The entry of computers in the design and manufacture has led to emergence of new areas, computer aided designs and computer aided manufacturing. As you know that computer aided designs and computer aided manufacturing leads to, or combination of this will leads to another field, that is computer aided engineering. So computer aided engineering, CAE, is a split or the sum of computer aided design and computer aided manufacturing. Traditional design and manufacturing are two distinct and separate activities. They are separated designs. We are doing the design separately and manufacturing separately. But coming to the this centuries or the recent day times, there is two combination, computer aided design and computer aided manufacturing are not separated. These are clubbed together in one industry or organization itself. So that will leads to SIM or CAE. SIM means CIM means computer integrated manufacturing, same as computer aided engineering. Computer integrated manufacturing is associated with the application of computers to the manufacturing of products from drawing office to dealers for marketing. Definition of CAD. Automation of design process. CAD means the automation of design process. This is a technology which uses the integrated design activities with the help of computers, which includes transformations and modifications of images of a part geometry, printing the images on a printer or a floater, and design data analysis. The use of computer system to assist in the creation, modification, analysis and optimization of designs. Modern CAD systems are based on interactive computer graphics, IGS, interactive graphic computer. So the definition of the CAD is simple, that it is a technology which is used to integrate the design activities with the help of computers. That means the computer is using for the integration of design activities. In this we can transfer or modify an image of a part geometry, or we can print the image on a printer or floater, or design the data analysis. All these activities we are using, or we are depending on the help of computer systems for the creation, modification, analysis and optimization of a design. The reason for implementing CAD systems. Why is the reason for implementing CAD systems? Why we are using CAD system nowadays? Or the rapid increase of CAD system is becoming more, as we told in the introduction part. Why it is happening? to increase the productivity of designers, to improve the quality of design, to improve the communications, to create database for manufacturing. As we know that from the CAD systems, the productivity of the designers can be increased because we can modify, recreate or redesign the product in the CAD system itself. In the traditional times, the designers, they are drawing the parts in a paper, so that they can't redesign. They have to redesign from the first itself. After the implementation of CAD systems, the redesigning from where the error happens, they can design from there itself. So the productivity of the designer increases, improve the quality. Same, the quality of the designs also improved because of the introduction of CAD system. Improve communication. Communication become easy. If a drawing or a part drawing of an objective is there, we can communicate easily. The drawings can be easily communicated to the dealers or to the persons who the designers want to to create the database for manufacturing. It's help a database for manufacturing of CAD. So CAD becoming a database for CAM, computer aided manufacturing. It creates a database. Historical developments. There are four major phases of development. 1915, the starting of computer graphics with the interactive computer graphics. The starting of the CAD systems are introducing. Cathode rays tubes, numerical controls, automatic program tools were introduced in that 1960 to 1915 to 1916 times. After the 1960 critical research period of interactive computers like sketchpads, CAD/CAM, that means computer aided design and manufacturing initiated, storage tube based turning key systems were introduced in 1960s 1970s. In that period, 1970 to 1980, the potential of interactive computer graphics were realized by the industries like IGES, computer graphic interactive systems like golden. It was a golden era for computer drafting. Wireframe models. Wireframe models means we will study it in the later classes, that the basic model structures are wireframe models. It was introduced in 1970s. In 1980 to 1990 time, the CAD/CAM Headley year for research, integration, solid modeling, synthetic curves and surface modeling came, solid modeling came. These are the second phase of wireframe modeling. Wireframe modelings were in 1970-1980 reached time period. In 1980 to 1990 times, the solid modeling, synthetic curves and surface games. That means surface modelings are introduced. 1990 to 2000, the management of CAD and CAM capabilities were introduced. SIM, like computer integrated manufacturing, EDM, PDM, calls virtual realities were introduced. Improvement in the communication medium and networking. Improvements are occurred in the medium of communications and networking. Reduce the cost of hardwares and softwares. That time, before 1980s, all the hardwares and softwares were more expensive. Later in 1980s, 1990, 2000 range, the cost of hardwares and softwares were reduced. Nowadays, in the recent times, the hardwares and softwares were cheaper in our time. In 2000, 21st centuries, 21st century, the wireless transmissions reduced the cost of high performance computing, reverse engineering, rapid prototypes came, reverse engineering were introduced. These were in 2000s. These are the main phases of development of CAD. Industrial look at CAD. The rapid development had taken place in the science and technologies such as Microelectrical computers, automations, telecommunication and networks were happened due to the rapid changes in the market demand and global economical competitions. The manufacturing industries face the challenge of networks, knowledgeable services and complexity. The manufacturing industries in the developing in the direction of automation, integration, network and globalizations. High-end technologies are being widely employed in many manufacturing systems to associate with the various product development activities such as marketing, design, process planning, production, customer service and other distribution at various locations into a integrated environment. Comparison of CAD with traditional designs. In the traditional time, the repetition of identical components is sometimes required, which again has to be drawn in the case of architectural designing and drawing. Designers have, in the case of CAD, can create a single window or other features that replicate it as many times as necessary. Difficulty to achieve higher accuracy while drawing by hand. Higher accuracy in designing is achieved in CAD. Highly time consuming. Traditional designs are highly time consuming, but in the case of CAD does not need much time for designing. In the case of traditional designing, the whole object is created on a paper using a chosen drawing tool like pen and ruler. In the case of CAD, users need to indicate the specific point, location and measurement in the drawing space. Then the computer generate or draw the object on its own. Application of computer designing. The main applications are coming. These are the design computers application in design. This is not CAD application. This is application of computer in designs. So recognition of need is the first step in the application. Then definition of problem. Synthesize. After the definition of problems, then synthesize. After synthesizing, the data will be analyzed and optimized. Then later optimization happens. After that, the evaluation and presentation of data surface. This is the general design process. That is the application for computers in design. Application of computer in design process. Last slide, it was the application of computer in design. This was the computer's application in design process. Traditional application was, as you know, left side, recognition of needs, problem definition, synthesize, analyze. This was the traditional part was in the last slide, and this slide one more, the computer aided design is also added. So from the synthesize geometrical models are adding, synthesizing the geometrical models are adding. Coming to the analyze and optimization. Engineering analysis means engineering properties or analysis. Engineering properties like anything, any engineering properties, stress, if there's stress or structural or weight, load, anything can be analyzed and optimized. If the analysis is not okay, it will go back to synthesize. Then the model will again geometrically models are built or remodeling are occurring. After that, it will come to analyze and optimization. Then it is okay. Then it will go to evaluation. In evaluation, design, review and evaluations are happening. If the evaluation is not okay, it will go directly to synthesize. If it is okay, it will go to presentation. In presentation, automated drafting, it will be drafted into the database. So coming to the applications of CAD, this is the application of CAD. Later slide, earlier two slides, it was the application of computer in design. So first application of CAD is structural design of aircraft. CAD analysis the turbulent flow patterns in aerospace structures. Second one is aircraft stimulation. Complex situations during the flight can be stimulated in the flight simulator using CAD softwares, which avoid lengthy delay, save fuel costs, and provides better than the pilots. Real-time simulations. It is possible to study the real-time behavior and inspection of critical parts subjected to repeat stress due to the mechanical loading. Fourth one is automobile industries. CAD provides various types of space curves for the aerodynamic designs of automobile surface. Fifth one, architectural design. CAD scan terminal scope in the architectural designs of bridge, building structure, etc. It is possible to estimate the building material requirement for a similar designs with different design parameters. Pipe routing and plan layout design. CAD design optimize the pipe layout and plant layout in chemical plants. Electronic industries. CAD is applicable in the designing of integrated circuit and printed circuit board design used in the electronic equipment or machines. Eighth one is dynamic analysis mechanical system. CAD design is useful for estimating the dynamic sources, reactive force of mechanical system at various time intervals. Kinematic analysis, similar to dynamic force analysis, CAD estimates the kinematic quantities such as displacement, velocity, and acceleration of various links for different configuration of mechanism. Mesh data preparation for infinity element analysis. The input data for FEA finite element analysis of a structure consists of geometrical and mechanical properties, loadings, and boundary conditions. CAD system generate the best meshing data suitable to particular problems. It is possible to represent data graphically to quickly guess the result.